All right, so we are starting this semester by talking about quadratic functions. A quadratic function is any function that can be written in one of these forms. F of x equals ax squared plus bx plus c, or f of x equals a times the quantity x minus h closed quantity squared plus k. A parabola is the shape of the graph of a quadratic function. So we're going to look at example 1 to show exactly what a parabola should look like. And we're going to look at the parent function here, f of x equals x squared. So in this function, I want to look at this table of values. I've already got some select x values shown for you. We want to find the output or the y values here. So if we square -2, might need to be careful about that by putting -2 in parentheses, and we square that. It is a +4. -1 squared is -1 times -1, so that should be a +1. 0 squared is 0. 1 squared is 1. 2 squared is 2 times 2, which is 4. And then I can put these points on my graph over here. So we've got -2, 4. So remember x first. So we go -2, +4, -1, 1, -1, +1, 0, 0, 1, 1, and 2, 4. Now I'm going to connect these. And this is generally what a parabola looks like. It's a little bit of a U shape. It bends. And just like our absolute value function, which was a V shape of some sort, it has a vertex. At this point, the vertex is the minimum value at 0, 0. It's going to either be a minimum or a maximum at the bottom or the top of the parabola. And the axis of symmetry is going to be a line that goes straight down the middle of the graph. So I guess I can show you our line first. If I had to draw a line that went right down the middle of this graph, it would be right there. And that is represented by the equation x equals 0. Just like when we did absolute value, the axis of symmetry is the x value of the vertex. And then domain and range, if you remember back when we talked about functions, domain and range refers to the set of input for the domain and output for the range, input and output values. So if you think about in this particular example, either with this graph or with the table of values, the domain, what kind of input values can I have? Any real number. So I can put any real number in for x and square it. So I would just put all real numbers, something along those lines. And then for the range, that's the set of possible output values I can have. And if you look here, there are some output values that we would never possibly get. Anything below 0 here, we're never going to get. So starting at 0 and going up is the range. So we could say something along the lines of y is greater than or equal to 0. Our y value can be any positive number, and it can be 0, but we never get anything beneath it. So that's one parabola, and I do want you to be able to get values for the graph, but it would also help to be able to know how to graph it using the graphing calculator. So I'll pull that up here. If we do a graphing calculator and we want to graph y equals x squared, it does look pretty similar to what we have here. We have a vertex at 0, 0. Can't quite see it right there, but we go through 1, 1. We go through 2, 4. We go through -1, 1. We go through -2, 4. So we can graph that there. Then I'm just going to do one more example like this for today. We are going to talk very briefly about vertex form today, and we'll talk more about it tomorrow. The vertex form is a specific way of writing a parabola. Any parabola can be written in vertex form. That was the a times quantity x minus h, closed quantity squared plus k, where the vertex is hk, because remember, you don't trust your x's, so you do the opposite sign, and that moves you left and right. You can trust your y, so the k moves you up and down. The axis of symmetry, like we said, is x equals the x value of the vertex. And then this value a at the front is going to tell you a couple of things if there's a stretch or a compression. So if we got bigger or smaller than the normal parent function. And then if we open up or down, a positive value of a keeps us opening up, a negative value of a keeps us opening down. So as you look in example 2 here, negative 3 over 2x squared, it's negative, so we know it's going to be opening downward. And 3 over 2 means there is going to be a stretch vertically for this graph. So just to kind of get an idea, that's not the calculator I wanted to use. So see what happens when x is negative 2. We've got negative 3 over 2 x squared. So when x is negative 2, we get negative 6. When x is negative 1, we get negative 3 over 2. Or you might know that better as negative 1.5. When x is 0, we still get 0. When x is 1, we get negative 3 over 2, which is negative 1.5. And when x is 2, we get negative 6. So because this graph has symmetry, if you find the vertex, the surrounding points should be the same. So again here, 0, 0 is going to be our vertex. And all of the surrounding points end up looking the same. So we've got 1, negative 1.5, negative 1, negative 1.5. So whether you go 1 to the right or 1 to the left, we have the same y value. And then we have 2, negative 6, and negative 2, negative 6. So here's our parabola for this graph. Again, the axis of symmetry goes right down the middle. So that's going to be the x value of my vertex. So x equals 0. My domain, again, is all reals, because I can put any value of x in here. I can square any number. I can multiply the result of that by negative 3 over 2. So that, again, is going to be all real numbers or all reals. And this time, what y values can I have? Since my vertex occurs at 0, 0, and I'm opening downward, that means the only y values I can have are equal to 0 or less than 0. I don't have any positive numbers. So this time it's going to be y is less than or equal to 0, because we're opening down. So the highest value I can get is 0. So the range is y is less than or equal to 0. So after what we've done today, you should be able to at least get a start on some problems relating to parabolas and quadratic functions.